Okay, we're going to look at areas under curves and also areas between lines and curves. So it's all about integration, but also there's some tricky bits of information that you're given to get started. So you told this, the line here is the normal. So this here is a normal to a tangent. So I've got to work out gradient at that point. So if I want the gradient at that point, I'm going to differentiate. And at the origin, x equals 0, so therefore dy dx is going to be 2. So that's the gradient of the tangent. We want the normal, giving you minus a half. So the equation of the line ON is y equals minus a half x. So let's find this point of intersection here. So we set the curve equal to the equation of the normal and play around with that a little bit. So let's throw it all to the other side. So therefore x is equal to 2.5 or 5 over 2. So that's that little point there. Do I need to know the y value? Not particularly. I don't think that's going to help me, so I won't bother. Now as I want this shaded area, if I just integrate the curve between my limits now, which is 0 and this x number here, 5 over 2, that's not really going to work because it's an intersection of a line and a curve, and I've also got negative areas. But when it's actually a combination, you can actually just subtract the curve and the line, in this case. So that's the curve, that's the line between the limits. That will actually give you the shaded region that you're looking for. I'll show you why that works in a second. So I'm just going to work this out now. Okay, so I've integrated that, and now I'm just popping those limits in. And that will give me that area under that curve straight away. Just giving me 2.6. And that's your area. Right, now what I've done is this is the same curve and the line, but I've shifted it all up. Now I worked out what the difference was. Go back to the original one. So I worked out what this difference was here, and it was 5 quarters. Okay, so this is 5 quarters down, and then using some graphing software, I've just moved it up that amount. Oops. So can you see we've still got the curve and the line, but everything's gone up now 5 quarters. So this point here is 5 quarters. So if I was to integrate the line between 0 and that point, so that's our 5 over 2, 2.5, that was our limit, you'd get the area of that triangle. If I do it for the curve, okay, between 0 and same limit, 2.5, I'll get the whole thing. The difference between them would give me that bit. So I'm basically integrating a curve, integrating a line, and just taking them away from each other. It doesn't actually matter that, sorry, there we go. It doesn't actually matter that it looks like this. It's still the difference between the two. Now you've got to be a little bit careful sometimes depending on what you've got regarding negative areas, but essentially you can just do one minus the other to give you the area that we were after. And that's it.